Hi and good evening. Hope you're having a great day. Today I found some spare time to continue reading documentation. I'll type along with the documentation itself just to get the notations in my fingers, so to speak. So we left off with the basic values and we'll continue from this. At basic, strictly speaking, a basic type is denoted by the Jakarta persistent basic annotation. Generally, the basic annotation can be ignored as it is assumed by default. Both of the following examples are ultimately the same. So let's create a new Java class that will be product, and it will be an entity. Let me just switch from the UK to US layout. Entity, it will be named product. It will have an ID because it's an entity, and add basic private integer ID. I'm missing here name next to the value. Okay, add basic private string stock keeping unit, add basic. I know that SKU is stock keeping unit because I worked in brewery for over 10 years and I wasn't testing beers. Name, add basic. I don't even like that much beer. A basic private string description. Okay, here's the product class, and simplified, it's actually the same without the basic notation. Great. The basic annotation defines two attributes. Optional boolean defaults to true, defines whether this attribute allows nulls. Jakarta persistent defines this as a hint, which means the provider is free to ignore it. Jakarta persistence also says that it will be ignored if the type is primitive. Just put my glasses on. As long as the type is not primitive, Hibernate will honor this value. Works in conjunction with column nullable, C column. Fetch type defaults to eager. So there is eager and lazy loading. If you want to load data upon fetching it, then you'll use eager. And if you want to be more cautious, you'll use lazy and then query the data once it's needed. Define whether this attribute should be fetched eagerly or lazy. Eager indicates that the value will be fetched as a part of loading the owner, and lazy values are fetched only when the value is accessed. Jakarta persistence requires providers to support eager, while support for lazy is optional, meaning that the provider is free not to support it. Hibernate supports lazy loading of basic values as long as you're using its bytecode enhancement support. And now that in my company I had an issue, not me, my team lead, I don't remember, but with lazy loading notifications. Maybe I can find the issue and showcase this also. Add column. Jakarta persistence defines rules for implicitly determining the name of tables and columns. For detailed discussion of implicit naming, see naming strategies. For basic type attributes, the implicit naming rule is that the column name is the same as the attribute name. If that implicit naming rule does not meet your requirements, you can explicitly tell Hibernate and other providers the column name to use. So entity is a product. Okay, if we in a database store the column for description as note, we would denote that here with annotation. Here we use add column to explicitly map the description attribute to the notes column notes. Okay, as opposed to the implicit column name description. The column annotation defines other mapping information as well, but see the Java docs for details. Formula allows mapping any database computed value as virtual read-only column. Formal annotation, so it allows mapping any database computed value as virtual read-only column. The formal annotation takes native SQL clause, which may affect database portability. Formula is a Hibernate-specific mapping construct and not covered by Jakarta persistence. Applications interested in portability should avoid this. So we would have like interest on an account. I do not have account. Let's create new class. Select account. It will be entity, and the name will be account of that entity. It will have ID. That will be long, and it will have private double, not double value, private double credit, private double rate, and it will have formula. It's Hibernate annotation, where the value will be credit times rate, and it will be stored in interest. Okay. When loading the account entity, Hibernate is going to calculate the interest property using configured formula. Scope in transaction. Let's see if I can run this application to be a bit more interesting. JDBC testing. I don't need the data source. I need standard service registry. Source, annotated classes, metadata, session factory, then open session. But I have here scope intersection. Okay, now I'll jump to bootstrapping the application. So we have it running, and then yes, and then it's wrong name, just it doesn't matter. What is this? Okay, and then we can test what we are writing actually against the database. Let's go to Bootstrap and we'll return to the code later. The term bootstrapping refers to initializing and starting a software component. In Hibernate, we are specifically talking about the process of building a fully functional session factory instance or entity manager factory instance for Jakarta persistence. In this chapter, we will discuss on a number of specific configuration settings. Be sure to check the configuration settings section as well for documentation for each available setting. Hibernate supports both native and standardized approaches for bootstrapping session factory, entity manager factory. Standardized bootstrapping. Jakarta persistence defines two standard bootstrap approaches depending on the environment into which the application is deployed and on how the application intends to access the entity manager instance from an entity manager factory. It uses terms EE and SE for these two approaches, but those terms are very misleading in a context. What Jakarta persistence calls EE bootstrapping implies the existence of container, EE, OSGI, etc., that will manage and inject the persistence contents on behalf of the application. What it calls SE bootstrapping is everything else. We will use the term container and application bootstrapping in this guide. If you would like additional details on accessing and using entity manager instance, Section 7.6, 7.7 of the Jakarta persistence specification covers container manager and application manager entity managers respectively. Container bootstrapping. For compliant container bootstrapping, the container will build an entity manager factory for each persistent unit defined in meta-inf persistence XML configuration file and make it available to the application for injection via Jakarta persistent unit authentication or via JNDI lookup. In these container environments, an entity manager may be dependency injected via at persistence context. In most cases, the lifecycle of such injected entity manager is managed by the container. Consider the following. Persistence. This is just the XML stuff, okay? Persistence unit, some name is a CRM description, persistence unit for Hibernate user guide, org, Hibernate JPA, Hibernate persistence provider, class, user guide document, properties name, Jakarta persistence driver, JDBC, this is the URL to the driver, user, password, SQL, okay. But we'll do here in a code, we won't use the XML. I think it was used in the past. We can inject the entity manager factory. Injecting a specific entity manager factory, add persistence unit name equals CRM, private entity manager factory. Because there is only one persistence unit, this one CRM, define we can also meet the name and inject the default entity manager factory. Okay, see documentation of your container for additional details. Application bootstrapping. Jakarta persistence also allows for application itself to manage bootstrapping of the entity manager factory. Reference it needs. This is achieved through Jakarta persistence or just Jakarta persistence configuration. Traditional way an application builds an entity manager factory itself is to use persistence, either persistence XML file or manually passing a map of settings. Okay, let's create an entity manager factory for our CRM. I'll delete this. No, yes, I'll delete this. I'll just the part that we have with create data source. Let's delete it. Okay. I'll see if I'll need it. So entity manager factory with Jakarta persistence EMF equals persistence dot create entity manager factory called CRM. Okay, and I'll just close this to have more space. Jakarta persistence also introduced a new way for application to build entity manager factory itself using persistent configuration, which offers a more type-safe approach. I like this approach maybe even more. Okay, let's just a second. Create the EMF of our okay. Let's do this. Let's do this. So final persistence configuration CFG equals new persistence configuration called entity manager factory. Okay, and I'll append property called JDBC URL. And it will be this URL. Just a second, some of this. Okay. No one. JDBC URL, copy, paste it here. Then we'll have following property called JDBC user, and I'll set this to test. Next property will be JDBC password. Okay, it will also be set to test. Oh, I saw a property called data source, JDBC data source, and I could set this probably to create data source. And then I don't need any of this because I have JDBC URL, username, password, and this is what we've done here. Hibernate offers an extension to Jakarta persistent configuration named Hibernate persistent configuration, which exposes additional conveniences. Let's try this out. Let's try and see entity manager factory, EMF. This is try with resources. Sorry, entity manager factory. EMF equals configuration dot create entity manager factory. What can I do? I can is open. Call in transaction. This sounds promising. Let's see assert, and now let's see. I'll just write out if it's open. What will happen here when I run this? The application must supply JDBC connection. Didn't it? Could not obtain connection to query database metadata. Unsupported production exception. The application must supply JDBC connection. But it's JDBC URL. JDBC data source, create data source. This is this one. Let's see what is wrong here. Let me just take the old properties and try it with this. And we'll double check what is happening. I'll import the static constants. And this is the URL to the database. H2, this is memory. Test. What will happen now? Now it works. And it didn't work with property data source. When I provide data source, create data source. Here it didn't work. Could not obtain connection. The application must supply JDBC connection. Strange. Okay, we'll have to investigate this later. Standardized bootstrapping and integrations. When performing standardized Jakarta persistent bootstrapping, Hibernate still uses its native under the covers. Therefore, all extension integrations points discussed in these sections are also available. It is especially useful in such cases that the integrations are discoverable as Java services. Native bootstrapping. Hibernate exposes its own approach for bootstrapping a session factory. A simplified approach using configuration, more controlled builder-style approach. Native bootstrapping simple. Configuration provides a simple API for bootstrapping Hibernate session factory. It is a collection of settings and mappings thrown together and used to build a session factory. Even simplified bootstrapping uses the builder-style approach under the covers, so the integration points discussed are still available. You can obtain the configuration by instantiating it directly. You can specify mapping metadata, describe your application object model and its mapping to a SQL database. You add resources, then you add class, parse annotation, parse edges class for mapping annotation, read package level annotations in the name package, and set property. There are other ways to specify configuration information, including place a file name. Oh my god. Place a file name Hibernate properties in the root directory of a class path. Okay. Pass an instance of Java util properties to configuration set properties via Hibernate CFG XML file system properties using Java. Native bootstrapping builder style. Bootstrapping a session factory may also achieved using a number of builders. This approach is broken into three core phases. First, a service registry is built, which represents the various services that will be available. An example of such a service is connection provider, which Hibernate uses to obtain JDBC connections. Next, a metadata is built, which represents applications mapping information, entities, embeddables, generators, etc. And finally, session factory is built. While more complex, these builders represents the actual process Hibernate goes through to build a session factory. And more importantly, illustrate the various integration points in bootstrapping process. Notice that the service registry can be passed at a number of points in a bootstrapping process. The suggested approach is to build a standard service registry yourself and pass it along to the metadata sources constructor. From the meta builder, metadata, session factory, and session factory will be picked up the same standard registry. Building a service registry. As mentioned earlier, Hibernate needs service registry, holding the services Hibernate will need during bootstrapping and at the runtime. Actually, there are two types of registries which are important here. One is Bootstrap Service Registry, which contains three important services. Class load service, which controls how Hibernate interacts with class loader. Integrator service, which controls the management and discovery. Strategy selector, which controls how Hibernate resolves implementations of various strategy contracts. This is a very powerful service, but the full discussion of it is beyond the scope of this guide. If you're okay with the default behavior of Hibernate in regard to the bootstrapping registry service, which is quite often the case, especially in standalone environments, then explicitly building bootstrapping service registry is not needed. If you wish to alter how the bootstrapping service registry is built, this is controlled through bootstrapping service registry builder. Bootstrapping service registry build, new bootstrap service registry builder, apply class loader, custom class loader, add integrator, and then build. The second registry is the standard service registry. You will almost always need to configure registry, which is done through the standard service registry builder. Standard service registry builder, new registry build, new standard. Okay. See the standard service registry builder Java docs for more details. The main integration point in this process is service contributor. Usually provides a Java service which allows contributing custom Hibernate services. Building metadata. To build metadata references, we first construct the metadata sources, which allows specifying the different sources for mapping information. This mapping information may be in form of XML annotations or both. Standard service registry, new standard service registry builder, build metadata sources, new metadata, add annotated classes, add annotated class names, read package level metadata, add resources. Also, methods on metadata sources offer fluent call chaining. Add annotated class, okay, add package, add resources. Metadata sources has many attributes, methods as well. Explore its API and Java docs for more information. Once we have source of mapping information defined, we need to build a metadata object. If you have specified everything as settings, you're okay with default behavior, you can simply call sources build metadata. Optionally, metadata builder from metadata sources, which can be used to configure the interpretation of mapping information. Configure second level caching, default catalog, default schema build. There are few integration points, usually provided as Java services, that hook into this part of bootstrapping. Type contributor, which allows contributing custom types such as Java types, descriptors, JDBC type descriptors, etc. Metadata sources contributors, which allows access to metadata sources to contribute additional sources. Additional mapping contributor. Metadata builder initializer, building the session factory. Once we have the metadata, we can build a session factory. If all configurations have been done by settings, or if you're okay with the default behavior, you can simply call build session factory, or a session factory builder obtained from metadata may be used to configure session factory creation, apply statistics support to. The main integration point here usually provided as Java service, which allows contributing custom Hibernate services. Common use case for integrator, for example, is to hook in custom event listeners. For example, I have my integrator that implements integrator. For it overrides the integrate method that takes metadata, bootstrapping context, and session factory. As you might expect, an event listener registry is the thing with which event listeners are registered. It is a service, so we look it up using the service registry. If you wish to have a custom determination and handling of duplicate listeners, you would have to add an implementation of duplication strategy contract like this. Add duplication strategy, new custom duplication strategy. Event listener registry defines three ways to register listeners. Set listeners, event type auto flush, default flush event listeners. Event this sets the specified listeners to beginning of the listener chain. Event type persist, default persist event listener, and merge also default. Disintegrate session factory implementer, session factory service registry. Here is now schema generation. Okay, let's go back to the domain model and basic types. Let me just check something out. Okay. Okay, let's try out this. scope EMF in let me see, scope in transaction. Do we have somewhere here scope? I have to I'll continue now. My daughter woke a bit, so I'll try to be a bit more quiet than I already am. So what I actually need to commit something to the database, I will need to get an entity manager, and then open a transaction, commit, and close transaction. So this would probably look something like emf dot get entity. Create entity manager. Then I would have entity manager dot begin get transaction and manager close. What we have commit. Let me see what we have here. Find, get delete is open, log, merge. Okay, get transaction. It will be transaction begin, transaction commit, and then on the end we would have transaction. This is it, and we'll have entity manager dot close. I think this would be the right procedure. And let me just let my cat inside. Okay, let's create this scope in transaction. Okay, in transaction method that will take the entity manager, account entity manager, find account class 1L assert equals. Let's just call this for start. Let's create a new account. Oh, you know, I have to register this class. Also here, it's managed class now. Okay, account.class. Account will be a new account. Account set ID. Oh, I'm missing getters and setters here. And let's also put here to string. Okay. Let's do one long. Account set credit to 500 and account set rate 1.25 or 100. Entity manager dot persist the account. This would, I think this would persist the account. Let's check on the database. I have pgadmin. Okay, and I'll create a table called account, and I'll have integer. It will be primary key ID of type integer, credit. It would be a type of, I don't know, is it float or it is double here, but SQL generate account SQL, and I'll just provide this. Okay, it will be, let's go from the start. ID big integer primary key, credit double precision, and rate double precision. Let's run it and see what will happen. Okay, it ran successfully, and now on servers, this is a test database. Okay, tables, schemas, public tables have the account. Amazing. And if I click on view first 100 rows, it's empty. Great. Let's go here to JDBC testing and run this part. And we can see that it ran insert into account, create rate ID, 3 things. And if I rerun this, I have ID of 1, create 500, and 0.0125. Awesome. And here I would have reading from the database. Account equals entity manager dot find account class 1L. This is the ID. Okay, and let's print out the account. Here it is. Okay, and it calculated the interest. Amazing. What was the interest? Credit times rate. Oh, 6.25. Let's just confirm it. 0.0125. Awesome. Wait a second. What I wanted to do next is to create this this like helper method that will actually do this thing for us. So let me create private static, let's call it in transaction method, and this method will accept entity manager, and it will accept the work, and work will be just a second. It's not provider, it's supplier producer. What is the name of function? I totally forgot. Haven't used them. It will be consumer. Consumer, okay. It will be void. Just a second, let me think about it. A method that will accept something. It will accept entity manager factory. Okay, and to do this work. What will it do? But here I want just to find. Okay, I want to define the work. Let me think about this. The method that will have one parameter and this consumer parameter will be entity manager. I'll remove this, and now when I call in transaction, this will be entity manager, and this, but I need to provide this entity manager no all as well. And I'll have this work done, It's not enough just entity manager. I will need this. So I will here have account this. Consumer would actually accept the entity manager, you know, and here it will have like entity manager one dot persist or whatever. But this is not the only thing it needs to have. I want entity manager to get transaction first, and then to start the transaction. Transaction begin, and I wanted to close transaction to commit it actually, and I don't know if it needs, probably, okay, let's do it like this. Okay, and now I can say, for example, this account, new account, blah blah blah. This is the method. Okay, I'll copy this. Account. Okay, I'll delete this one, and I'll delete everything from this. And I'll just, okay, put entity manager here. And I'm sending entity manager to the in transaction, and I'm using consumer. Let's see. Okay, already exists, so it might work. Let me check it now. And I think it's now persisted. Let me just take, I'm back. So let us see what we can additionally do. I feel stupid for not remembering consumer, but never mind. Let's pull here maybe the entity manager factory, EMF, and we'll also use entity manager factory to create entity manager. Entity manager, okay. And then we'll use this get transaction, begin, we'll do work, commit. This is okay. And but I can do this in a try block. I don't know what are the, okay, here, okay. And if I don't know, catch exception, if something happens, then do transaction rollback. This is like returning to the previous state. And finally, I want to close the entity manager. Close. Okay. Try can use automatic resource management. Does entity manager has closable? Yeah, it's auto closable. Okay, then I'll put this here. Okay. Oh my god, EMF create entity manager, var entity manager, and then is transaction auto closable, but I don't close it. Then I'll use here entity manager get transaction, name it, and remove this. Now it cannot resolve it. Now let's pull it outside. Just a second. Let's bring it back. And now entity manager get transaction. It doesn't want to do this. And finally cannot resolve this. Because it's scoped to this try block. Okay. No, I don't need to pass this. I need to pass entity measure factory. Yeah. Okay, but I can now do like, I was wondering also one thing. I saw that there is on entity manager, there is never mind. Entity manager persist. Okay. And then I want to persist the third one, and I want in transaction I'll provide entity manager factory EMF, and I want to entity manager find entity class. It's called account.class, and I wanted to find the 3L. Is there a find all? It's not. It inserted the account and it didn't find it. Maybe because it didn't flush it at that point. Maybe now it will have it here. Let's see now. Okay, maybe I'm retarded. I'm just not printing out the account. Okay, let's just do this once again. 5, 5, and let's print out the account. count, and let's go. Okay, it's here now. The SQL fragments. Oh, I just want to check something else now. Entity manager. Create native query. Select everything from account. And entity manager. Okay, I have create query. And what can I do with it? Let me check the chat. I'll check just how to get all accounts. List account, entity manager, create native query. I was just missing get result list. And now when I put variable list, result list, but I'll put it as account. And uncheck the assignment, Java util list, Java util list of account. And let's list for each south. And I want to insert new things in the database. Select everything from the account. Let me run this query here. Okay, it's running okay. Let's see what's happening here. This is strange. Intersection, I have a list of accounts. Entity manager, create native query, get the result list, accounts for each account class. But why it's not showing anything? It's selecting error code 0 state is the column. Okay, nothing to show. For each let's do this south one. What will happen now? The column name inches was not found in the result set. Oh, interesting. This one. Maybe if I use session factory instead, Let's do this Hibernate persistence configuration, and then session factory create manager effect, not manager, create okay, maybe if I leave it, maybe it will still work, but I'm not 100% sure. Or will it complain? No, it's not found. Okay, I don't know how to ignore this. I'll have to check. How can I ignore this for entity manager? Formula is already ignored. For insert an update, Hibernate will never try to save, but it's not ignored when loading. Okay, if using native query, include the formula manually. If you want entity measure to completely ignore interest, use transient. Okay, let's use transient. And let's see what's happening now. Now it will print out one, and it will also print out the account. Okay, I can return this to persist configuration and this just to print out. Okay, now it will work. Awesome. Mapping basic values. Okay, we'll stop it here for tonight. And continue tomorrow from, I didn't move much from documentation, but hopefully tomorrow I'll cover more of the things. Thank you for tuning in. Bye bye.